Awesome. Okay. Well, welcome to the final presentation in our Get Your Head in the Cloud series from the Portland Python Pirates. My name is Chris Thompson, captain of the captain and founder of the Portland Python Pirates. You can visit our website at pythonpirates.org. We're kind of in the process of building out our new site. So right now there's link to our Slack channel if you'd like, and also a tab with a bunch of resources. Soon there will be much more hosted there, so stay tuned for more on that. But let's get going. Tonight's presentation is going to be about Kubernetes, and then we're going to dive into GKE and launching your Python applications on there on, if you don't know, Google Kubernetes Engine, but we'll refer to it as GKE, so I don't have to keep saying Google Kubernetes Engine. Thanks to our sponsors, the Tech Academy. Tech Academy's a boot camp dedicated to getting the future tech leaders skilled up and out in the workforce. They have programs on software engineering, data science, and I believe like DevOps type stuff. Anyway, for more on their programs, you can go to Tech Academy website and check them out. They usually give us a free space to host our meetups when we're in person. Right now we're remote, but we hope to get back there soon. And then manceps.ai. Manceps is a machine learning company looking to bring machine learning solutions to enterprise organizations. If you're interested in more on them, check out their website, manceps.ai. They are also, I don't know if they're hiring currently, but they do have a careers page. So if you're interested in a local Portland-based machine learning environment, definitely hit them up, and they may have a spot for you. So guiding principles, we are inclusive. So all skill levels, all backgrounds are welcome. We're Python focused. And I say that as we're about to not do barely any Python tonight, but we're Python focused. We use other languages when we need to, but mostly we stay on point with Python. We do progressive learning. So this series was kind of started pretty easy, and then we went up to more complex things. And we kind of do that throughout the year, where we start on easy stuff and build up to something a little more complex, which is kind of what you're experiencing right now, is kind of the end of our year, where it gets kind of peaks out, and then we usually start up again, I don't know, around Thanksgiving or sometimes beginning of the year, with more introductory stuff again. So we will have a comprehensive Python programming course coming up that'll be free for everybody, textbooks, videos, all sorts of stuff. So stay tuned for that. For more information, we'll probably post it on our website. So definitely check back there periodically, and we'll let people know on our Slack channel once we post stuff about that. We're collaborative, so feel free to jump in, ask questions. You can put them in chat, or you can jump on the mic, either way. A pretty small group obviously tonight, so not worried about interruptions or just having a conversation. Usually when there's less people, it's a little more relaxed, and we kind of just chat back and forth, so that's totally fine. Don't be shy. Okay, so this is a comic strip that I found, and I've seen it before. I think it's super funny. His boss is like, I need to know why moving our app to the cloud didn't automatically solve all our problems. Gilbert's like, you wouldn't let me re-architect the app to be cloud native. And boss is like, just put it in containers. He's like, you can't solve the problem just by saying techie things. And he says Kubernetes, right? And this is kind of, it is funny, but it's funny because it's kind of true. Everybody just wants to, use Kubernetes or use containers or go to the cloud and all those types of things. And it's not as simple as it seems, and also as cloud companies make it seem. They always have these really easy looking demonstrations that they give, and we're going to do one of those tonight. But there are many other things that kind of come along with that, and we can address that if you want tonight. So tonight is deploying your app on Google Kubernetes Engine, like I said. So I'm going to show you, this is kind of a poor choice of words, but Kubernetes Resources. Just some books, labs, and an actual course that you can take on Google Kubernetes Engine that's really comprehensive and will get you to kind of an intermediate level, I would say, on Kubernetes, or on at least GKE. Then we'll do an introduction on Kubernetes, which will be fairly comprehensive. Hopefully, I just want to set a base level of understanding before we just start launching stuff on Google Cloud, because it looks very, very simple on Google Cloud, and it is to a certain extent, but it's also good to have basic knowledge about Kubernetes before you just start launching things into the cloud, like Dilbert's boss would have them do. And then we'll go into a demo. So I'll drop the link in the chat, and in fact, I can do that right now. Let's drop that link. To follow along with this, you'll need to have a billing account set up. I think I put that in the meetup description. If you don't have that set up, you can just watch and then go and do it yourself after. Again, this video will be recorded, or this session will be recorded. So feel free to refer to that. And then any questions you have, we can do that at the end. Let me get my headphones on here. Okay. So let's dive in. So first, so the course, as promised, so here's a link to the course. This is a really, really good course on Coursera. It's called Architecting with Google Kubernetes Engine. Highly recommend that course if you're looking to use Kubernetes. They did a really great job with that course, and have actually revamped their courses. Oh, good, nice. Yeah, it's a new one and a good one. I have an O'Reilly subscription, so I was seeing those what do you call it, the pre-release. I was getting real excited for it, because man, there's just some times where you just need to do a very specific thing. It's so useful. I use it. I've already used it a whole bunch, so that's cool that you have that. And then quick labs. So here I actually I'll drop this in chat. This is a direct link to like their Kubernetes offerings on Quick Labs. So they're like a bunch of interactive cloud labs that you can do that kind of familiarize you even more with Google Cloud, from very specific to just an overview of Google Kubernetes Engine. So definitely check that out. You just buy credits and then you can just use them on the labs. Really cool offering. So the Kubernetes book, I'm going to copy this link address. I found it for free online. If you want to support the author, definitely pay for it. Nigel's a really, really great instructor. He does the Kubernetes courses or part of them on a Cloud Guru, and wrote this book, and it's just really awesome. So definitely check that book out. Buy it if you want to support him, but there's a link to the free version it's up to date as of like September of last year, so there may be actually a newer version, the 2021 edition or whatever, so it might be worth actually getting the new one. And then here is the Google Cloud Cookbook that is brand spanking new. Like I said, it's very useful. Someone already has it. It's awesome. Jordan already has it. But really good for very specific things. Like I need to stand up my application on Google Cloud or GKE, just say GKE. GKE. It has stuff like that. So if you need to do something very specific, definitely check that book out. It's awesome. It's got a whole bunch of stuff on networking and all the Google Cloud services, just anything you need to do. So okay, so let's get into it. We've seen this diagram. If you've attended any of the prior meetups or sessions in this series, you've seen this diagram. And this diagram kind of shows all of the compute resources available on Google Cloud. And you see the spectrum down there. It goes from minimally managed to highly managed, right? Highly managed meaning the infrastructure is kind of handled for you. Not kind of, it is handled for you by Google Cloud Platform. Right, so Google handles all the underlying servers, and that includes updates and security. Like all that stuff is handled. All you have to do is launch your code, or give them your code,
and they will deploy it for you, and you have an application up and running in minutes, or just any piece of code, whatever it may be. So you see here, it starts over far on the right-hand side, Cloud Functions. Cloud Functions are really cool. We didn't go over those just because it's kind of, and maybe we will in the future, but Cloud Functions is a way to put your code just up on Google Cloud, gives it an endpoint, and usually are not full applications, but Cloud Functions can be linked together via like something like PubSub or whatever, and PubSub is akin to Apache Kafka, so a publisher subscriber type service. And what that does is allows you to build out microservices that are kind of detached, and they have HTTP endpoints that are stood up for you in front. So if you're an AWS person, this would be like what's the service called? Lambda functions. There we go. AWS Lambda, right? Same kind of idea. So those are fully managed. You literally just put your code there. You do nothing else, and it handles all the rest of it for you. And when we start moving to the left, we get App Engine, still relatively easy. You can actually stand up in a really large application. Lots of people, that was like one of the original Google Cloud offerings, and very popular. Kind of being phased out with the rise of containers. I don't see people, I mean, App Engine is obviously still used, but you know, with the rise of containers and microservices and all this kind of stuff, you know, App Engine is kind of falling to the wayside, and people are going in favor of like Cloud Run or Kubernetes Engine or even Cloud Functions, right? Because it's kind of the same idea of this microservices architecture, right? So you can build stuff like that with App Engine, but it's not really meant for that. It's meant more for like kind of just a single application, right? If you're going to go with microservices, any of these other offerings would probably be much better for building something like that. So, but still very managed. So you give them your code, they launch it, and networking's handled, infrastructure's handled. Like it's just for developing applications, right? You worry about your code. Cloud Run starts to be a little less managed, right? Like, so you have to containerize your code. You write your Docker file. You hand it over to Cloud Run. But what Cloud Run does do is it manages scaling. It does manage infrastructure, all that kind of stuff. There's a little more configuration involved, but what it really is under the hood is managed Kubernetes. So it runs on top of something called Knative, and Knative is kind of this managed Kubernetes. It is managed Kubernetes, and so you are able to utilize, take advantage of many of the benefits of Kubernetes without too much configuration, or as much configuration as Kubernetes takes, right? But then we get GKE, right? And compute engines on the far left, just think VMs, right? Those are just straight vanilla VMs. I mean, there's lots of them. There's tons of configurations and all sorts of stuff, but you manage everything, okay? So like everything, all of the operating systems on the inside, like updates, like all that kind of stuff. And you can configure kind of auto updates, but more or less it's on you to manage networking and everything, right? So all these other services handle that for you, and Google Kubernetes Engine is one of those, right? Like, so Google Kubernetes Engine is I gotta say GKE. GKE is a service that is it abstracts a lot of the heartache of running Kubernetes clusters. It abstracts that out, and that's really nice because it allows Kubernetes administrators to kind of worry about other things besides the nodes that the containers are running on, or the networking, or any of this kind of stuff that if you've ever tried to do Kubernetes on bare metal or on, you know, some other, like your own computer even, there's lots of different ways to do that. It's hard. It's not easy, right? So we'll look at what that means and why that's important. So just an overview. So what is Kubernetes, right? What are the features? Well, Kubernetes has lots of benefits. Like, and what problem does it solve? It solves orchestrating containers in a production environment. Okay, so you know, you can build a one-off container, you can run it on your machine, it'll work, you know, but once you want to build a bunch of containers, maybe all of those containers make up an application, and you want to put it into production, there's lots of weird things that start to happen and difficult problems that you need to solve, right? Like scaling, right? Scaling containers and you know, what if a container breaks, right? How do you bring up another container? How do you replace containers with a newer version or roll back containers to an older version of your application? And how do you handle that for either a subsection of your application or for all the containers in your application? And how do you do that without interrupting the service to end users, let's say, right? So all of these things are very, very complex, it turns out. And Google has been working on this problem for quite some time. And Kubernetes was actually developed internally at Google and then released, they could say it's gifted to the open source community. And it's a container orchestration system. So it comes built in with things like intelligent scheduling, self-healing, horizontal scaling. When we talk about scaling, when you hear vertical scaling is when you're scaling up resources like in a single node, right? Like CPU, you know, you increase the CPU, you increase the memory, you increase whatever, right? So that's horizontal scaling. Vertical scaling. Horizontal scaling is we have a bunch of smaller machines, but we make a bunch of them. So scaling out, right? So you have a bunch of replicated like nodes. And so you do that instead of trying to increase the CPUs or increase the memory. You just have the same CPUs and memory, you just have more of them, right? So horizontal scaling, and so on and so forth. So all of these are to solve many problems that Google realized when starting to use containers. And so if you want more on that, I believe Borg was the name, Google Borg. Hold on, let me see if I can get that link. Large scale cluster management. Yep. That's the one. Here, I'll drop this if anybody's interested in academic papers. There you go. That's the Borg paper. There's also lots of other things on Borg. I mean, just on the Kubernetes website or whatever. But it's interesting to read about and how Google came to develop Kubernetes and why they realized it was necessary. Okay, so let's talk about architecture. Now, this might make your head explode. Looking at this, right? It's complex and for good reason, right? There were lots of things that they wanted to have happen and didn't want to have to think about as much. So let's step through this diagram a little bit, and then we'll go to GKE, right? So this diagram will inform why GKE is necessary. Okay, so we have we'll start here on this master node. So this section right here, we'll call it the main node. I know master has been started to be phased out. So on this main node here, we have something that's called the Kubernetes control plane. Okay, and what this is where all of the things that make Kubernetes kind of happen live. Okay, so we'll start here with this API server, right? And the API server is just what it sounds like. It's an API that basically is used to create Kubernetes objects. So there's in Kubernetes, there's things called objects, and there's many different kinds of them. They always have a kind. Okay, and we'll talk about what a kind is. Okay. When we look at these deployment YAML files in just a little bit. But the API server is where you say, hey, Kubernetes, you know, I have this application that I need to run, and I need a deployment object. Or in this case, we can start with, let's look here. You see this thing's called pods. So, you know, you would ping the API server, right? You would say, hey, give me a pod object. And the API server would be like, all right. And what you do is you give it a YAML file, right? You could also give it JSON, but that's messy and annoying. YAML is not the greatest thing in the world, but it's much more human readable than JSON and easier to manage than a JSON object. So YAML is the preferred way to give things to the API server, although JSON is accepted. So you give the API server a YAML, what they call a YAML template, and the API server reads it, and they're basically instructions for how you would like the API server to build something. Okay, so let's say you want to build a pod. So you contact the API server through a utility called kubectl, also referred to as kubectl. And that kubectl sends an API request to the API server and says, give me that object. The API server then will interact with controllers and a scheduler, right? And produce an object. And in this case, let's say it's a pod. And that pod will be scheduled onto a node, right, based on that deployment YAML. And there is a controller that will begin to then monitor that object, right? So a controller, right, you'll see a lot, there's a ton of different kinds of controllers in Kubernetes. And all a controller is, think about it as a while loop. And that while loop is constantly looking at the different things it's supposed to look at. There's different types of controllers. But it constantly looks at the different things that it's tasked with looking at, and it will say, is it okay, right? So in this case, there's a controller that looks at pods, and it says, hey, this YAML told me that there should be 3 pods running on each node, right? Is that true? And it continues, it continues, continues. So this is that part where we said, what happens if a container dies? Well, let's talk about what a pod is. So a pod is actually the smallest unit in Kubernetes, okay? So you might think it's a container, but that's not necessarily true. So Kubernetes only knows about pod objects. Each pod object can contain multiple containers, okay? And so what you'll have is you'll actually scale up pods. So you can have one container, you can have multiple containers in a pod, but a pod is like the smallest unit. So when we talk about scaling up, you're scaling up pods, not containers. It's really important to understand. Okay, so when you think Kubernetes, think pods. So that's kind of controllers. The schedulers, like I said, will schedule these pods on nodes depending on what your deployment YAML or your YAML, I should say, says. You have to be careful with lingo, and you'll see why later. There's this thing called a key value store, right? It's an etcd database, and what that etcd database does is it interacts with the API server. The API server writes the state of the world in there, the state of the Kubernetes world. So when you create a new object, or if you destroy a new object, or if you change an object, so kind of these CRUD operations, right? Create, update, delete. This etcd server stores that state so that anytime the state changes, we know what it was, and now we know what it should be. And the controllers, the scheduler, all now have that information, and that's how they make determinations, right, on how things should be, right? So that's how the scheduler knows what node to schedule a pod on. That's how the controller knows how many pods should be up and running at any given moment, right? That state is stored in this database. So that's what that's for. And so the API server also, so that's the Kubernetes control plane in a nutshell. It's a little more complex, but that's the basic idea behind it. So then you have the API server interacting with the kubelet. Okay, so this kubelet is kind of a, let's kind of think of it as a worker for the API server. And it tells, it basically gives what the state is on each node, right? So it keeps track, this is its domain. It's just this node, and it interacts with the Kubernetes control plane to let it know information that of what is happening on that particular node. All right, and so pretty straightforward, right? It's just keeping track of things on each node, letting the mask or the main node, right, the Kubernetes control plane, know what's going on, okay? And vice versa, the Kubernetes control plane can then tell the kubelet what it wants it to do, right? Or what needs to happen. So it's kind of this back and forth. That's why you see this double arrow here. So we have pods. We went over pods a little bit. The container runtime, so the container runtime in this case would be Docker. There's other ones, containerd, like there's all sorts of runtimes on that will run your containers, right? There's all sorts of different ones. In GKE, it's not Docker. I wonder if it's containerd. I forget what the runtime is in GKE, but so there'll be a container runtime to allow you to run your containers. And then there's the network proxy called the kube proxy. The kube proxy handles everything networking. So you don't have to tell it, how to route requests, and you don't have to tell it, how to speak to another service within, right? Like everything is controlled by this network proxy. And so it has an IP address assigned to it, and it knows how to route requests, right? All of that is just built in. So this is all very technical stuff, but honestly, it's all built in. So you can learn this over time, but that will not stop you from using Kubernetes, because that is the point, right? You should be able to just use it. And it sounds complex at the beginning, and it is. It's a lot to wrap your mind around. But once you get this idea of YAML files and what's called declarative configurations, it becomes much simpler, and you realize how powerful it is. So then you see end users, right? They'll send requests to really, there should be, this is a little simplified, and we'll see that here in a minute, but they send the requests to the cluster, and the cluster routes their requests to the proper nodes, the proper pods, and sends information back to them. Okay. So we saw Kubernetes, and that would be a vanilla Kubernetes, right? Like, so if we were to launch Kubernetes onto just a server that we own, or even some virtual machines or something like that, right? Like if we were dealing with our own nodes, well, the problem with that is we need to configure those nodes, right? So we would handle the networking, we would handle the storage, all that stuff we talked about earlier. That's where GKE comes in, and this is what makes GKE very powerful. You can see how complex this can be, right? Well, what GKE says is, hey, you shouldn't have to worry, right, about the Kubernetes control plane. You shouldn't have to worry about these resource controllers, the scheduler, the etcd, the API server. Like all of that should just be out of sight, out of mind, because it should just work, right? That's what the goal of Kubernetes was in the first place. If you're a Kubernetes admin and you're not on GKE, say you're just, like I said, on some servers or VMs or whatever, like that's tough. Like you have to actually manage what we were just looking at a lot more, and it's a headache. Like when something goes wrong, it's bad, right? So here you can see, so here's our GKE, and they say a zonal cluster. So in this case, it's in zones. GKE is also regional, which we'll talk about in a second. But in this case, we'll start with a zone, right? Which are contained in regions, and we're talking about geographic regions. Okay, so there's geographic zones within geographic regions all around the world. So here, right, if I'm a developer, here's my kubectl, sends my request to the API server, checks out the etcd, makes sure that, what the state of the world is, then launches, lets the controllers know, hey, I need to do this thing. The scheduler says, oh, okay, we need to schedule some pods on the nodes, right? The workflow we just went through. Well, we see these nodes here, and you realize that, or you should realize that these nodes, all of that is handled for you. So when I say I want a 3-node cluster, GKE says, all right, and it just spins up 3 compute engine VMs for you and handles all those VMs for you. So there's a Linux operating system that's on there. It's not like Ubuntu or anything. I think it's a custom Linux operating system. And so all that infrastructure management kind of gets taken out of the equation. And the only thing you really need to worry about are the resources living on the nodes, right? So all you're doing really is configuring how your application should look on Kubernetes. All the rest of that, the control plane, the nodes, that's all abstracted out. So you shouldn't say never, but you don't need to worry about infrastructure unless you're doing something very, very fancy, right? I mean, you can define, right, your nodes. Like it's not like you can't say I need this many CPUs, this much memory, this much storage, whatever the case may be, right? Like that's still a thing. But in terms of managing updates and all of that stuff, handled. Don't worry about it. And that's really nice. for Kubernetes administrators or anybody using a Kubernetes cluster. So what do you worry about? Well, you just worry about all this stuff over on the right hand side, kind of your VPC, so your general network that the cluster lives on. You worry about maybe some persistent storage you need. You worry about load balancing, right? How you want load balancing to happen. And then any other interactions with like cloud services, right? Like on Google Cloud. So what's really nice, and let's go to the next slide. What's really nice about GKE, right? Here's some of the benefits: is it manages the control plane, and you're not billed separately for that. So that's really important, right? Like they just handle it, and that's not a separate billing thing. Like you don't have to pay for the compute that it takes to manage the Kubernetes control plane. Like that's handled for you. So all you worry about is the compute that you're using, right? Like the work for your workload, and that's cool. Like that's really cool, and it's billed by the second. And so GKE deploys and manages compute engine instances as nodes. We just talked about that. The zonal and regional clusters are available. So for high availability, right, if you're in one zone, and a zone you can think of as akin to like basically a Google data center, right? If a data center goes down, right, which is not unheard of, right, that would mean like that zone is down. And if you only have your cluster in that zone, well, that sucks because your application just went down, right? Which kind of defeats the purpose of Kubernetes anyway. So what's really cool is you can have your cluster regional, right? So it's actually replicated, right? So you have a node in zone 1, a node in zone 2, a node in zone 3, and you can have a load balancer, right, sitting in front of that, like a regional load balancer that will direct your traffic, right, to where it needs to go, either the closest zone, right, to any given person, or perhaps the one that has the least utilization, or let's say the one that's up because maybe one of them's down, right? Like so your load balancer handle that on the front end, which is super cool. And then the control plane, right, integrates with other stuff like cloud monitoring and cloud logging. So you get logs and monitoring and stuff. And the coolest part is you don't have to have an external IP address. So that means that it's very secure, right? It lives within Google's infrastructure and within their networks. And so you can use internal IP addresses to communicate not only with cloud monitoring and cloud logging, but also with other Google services, Google Cloud services. And so you stay within your virtual private network, and you never have to leave that safe zone, right, to get stuff done. And that's cool too, right? And these are more security type things, but it's always important to be thinking about security. When the cloud is secure, but it's only as secure as you make it, right? Like Google handles a lot of the data center security and a lot of other things, but it's your job to handle security of your resources and your virtual private cloud. So always remember that this is a shared responsibility model, not just like offloading security to Google Cloud. And then you need the ability to access Google, or you have, I already said that, ability to access Google resources without the need of an external IP address. So that's very, very cool. That's very nice. Really secure, because Google owns and actually has the largest private network in the world. Okay, it spans the entire world, and you never have to touch the public internet, which makes launching applications and being on Google Cloud probably the most secure cloud platform, honestly. Okay, so I'll stop there. We're gonna do the demo here in a sec. I just wanted to make sure there aren't any questions on all that crazy stuff I just talked about. If there's just like, if you're just confused in general, that's totally normal. I remember when I was first learning this, it was very intense. So no worries. It takes a while, but hopefully that cleared things up just a little bit more, you know. So let me get this going, and feel free to ask questions if you have them. Switch over here. Whoa, that's small. All right, let's blow that up just a tad. If we can. Yeah, I wish I could just increase the size of this. Can I do that? Where's my settings? Oh, right here. Terminal settings. Oh, dude. Let's see. Maybe it's. Hold on. Settings. Oh, I need to reconnect. That's why. I was like, why won't it let me do my settings? So where I am right now is in my in my cloud project, right? I'm using this Pirate Stocks just because it has a billing account attached to it, but it's not for any particular reason, right? It's not called that for any reason. It's just it was a project we spun up for other things as well, and so it's just the easiest way to go. Let's see. Here we go. Font, text size. Let's go to large. Let's go to, that's good. That should be good. Everybody good with that? Thumbs up from somebody, or just drop it in chat. Make sure that's large enough. Can't tell. I'm gonna start going, let me know. Okay, so I think I dropped that link into chat. And we'll put it in the video description on YouTube as well. Okay, so what we're going to do is we're going to actually write a simple app. We're going to launch it onto Kubernetes. We'll look at our cluster, right, and kind of examine the different components of what we were just talking about. We'll also take a look at a couple of those YAML files we were talking about. And we'll talk about the difference between imperative configuration and declarative. Kubernetes favors a declarative style, and we'll talk about that. So let's take a look. I already configured many of these files before. Okay. So let's look at our Python file first. You know what we can do is something fancy. So within your Cloud Shell, which is a small VM that they allot you, you get 5 gigs of storage, so a persistent disk that gets attached when you open it up. It has access to all the Google Cloud APIs that you have enabled, and then it also, which the editor did not used to be this nice. It used to be like their own proprietary editor, and it wasn't great. I mean, I would still do stuff in it, but it wasn't that great. But here you can see this is VS Code living on your VM that is already integrated with your Google Cloud Platform project. So you could actually do a fair amount of development work here without the need to ever leave the console, right? The Google Cloud Platform console. And that is amazing. That is super nice. And you get all these fancy things like, this is Cloud Code, which is available on, I think it's available on PyCharm and on VS Code. And this is a way to look at your different services. So there's one for Cloud Run, there's one for Cloud Build, there's one to look at just the APIs. Like you can interact with Google Cloud Platform through this, and it's really cool. So definitely give Cloud Code. Maybe we'll do a session on that in the future because it's really fun. But okay, so let's look at our files. So we have this app.py here, right? And you see it's very simple. It's the classic Flask Hello World application, which you'll see in a lot of Google Cloud demos. And if you don't know Flask, don't be afraid of this. It just spins up a server to basically serve up this application, and all this application does is gives you it returns hello world, and we'll be able to see it in a minute. And you can configure it to say something else. So notice this os.environ defaults to world, right? But you can actually set it as it reads in the target environment variable. So if we wanted it to say like hello John, we would just set the target environment variable to John, and it would say hello John instead. But I don't know. We don't really need to do that. This isn't a tutorial on Flask, so we'll probably leave it as is. But feel free to play with that when you go and do this by yourself. Okay, so this is our application. That's it. This is the only file we have, right? This is not so much a Python demonstration as it is for GKE. So this will be a simple file that we can use to demonstrate. And you see here, we went over Docker files in Cloud Run. So we talked about the Docker file. I definitely encourage you to go back and look at that. Also, just look at Docker's website. They do a fantastic, their documentation is really, really good. Like some of the best I've seen. Which is not true of all things. So definitely check out their little tutorial on Docker files. Google Cloud also has an explanation of Docker files that is pretty good. So If you're not familiar with this, check it out. But basically, these are instructions on how to build a container, right? So we're going to use a base container. It's a Python 3.7 base container. Those are usually Debian containers. It sets an environment variable. The app home is app, and then it uses that. You can see here, this is kind of best practice, right? So it uses that environment variable here, and it just sets that as the current directory when this is being built. And then it copies files that are relative to the Docker file. So this is why we have a Python directory here inside our quick start, because we only want this app.py file, and there's ways to specify that. I mean, you could, but it's nice to just copy everything here, and everything relative to the Docker file, meaning everything inside this directory will get copied. The only thing that's relative to it is app.py, so that's the only thing that's inside the container once it's built. And then the command that gets run when the container is run is this. And Gunicorn is a production type, a production server, a Whiskey server. If you know Whiskey, just another Whiskey offering. And it basically just runs our app. So here we say run our app, use 8 threads, 1 worker, bind it to this port, done. Okay. For more on that, definitely check out more Flask tutorials. There's tons and tons and tons of them. Flask is nice for building relatively, I don't know, there's kind of this gray area where that you cross at some point where Django may make more sense. Flask is great too for applications. So I learned on Flask. I've been thinking about honestly going to other things like Fast API or Django or whatever, but I'm very familiar with Flask. It's just another way to build web applications in Python. So definitely check out Miguel Grinberg's Flask Mega tutorial is really great. He also wrote the book on Flask. The O'Reilly book is really, really good on Flask. So check that out. Okay, that was a long explanation for Flask. Anyway, it just runs our application. That's all it does. Okay, our simple application. Okay, and so those are those files, and we'll take a look at these other files a little bit later. It's not totally necessary, I feel like, right now to check those out. And what's nice, right? If you're familiar with VS Code, you actually get this built in, right? So you get your terminal as well, so you never even have to leave this environment. So we can just chill right here, and it's all good. Unless it's going to be too small, it's right. I have to look the text. Let me see. Let's go to terminal. That's probably better. Let's go here. Well, you can stay there, but I'm going to do this for demonstration purposes so everybody can see. Okay, so there's our stuff, right? And we also have this file that is in here, the secret file. It's a hidden file, right? It's called a Docker ignore. Okay, and so to see what's in that Docker ignore, right? What it's doing is it's going to ignore some files, right? These are common Python files that are used that are not necessary to run your application. Right, they're just used when you run a Python application. So if any of those get created, we do not want those to end up in our container, right? And so what a Docker ignore is, it's very similar to a Git ignore. If you're familiar with a Git ignore, there's other such ignore files, and all they do is say, hey, when I do this thing, whether it's pushing code to GitHub or whatever repository, and or building my Docker file, like don't look or don't use these files. If you see these files, leave them out. I don't want them. Okay, so it ignores those files. Right? Okay. Okay, so you can see here, whenever you're in the shell, you can always get your project ID from right here. It's also available if you use the gcloud command. So gcloud config get value project. And you can also get it there. So pirate stocks, right? Cool. And then what we would do is we want to create a repository. So Google Cloud actually has a Git repository, cloud repositories. So you can either create a repository on Google Cloud, or you can mirror a repository that's somewhere else, either in Bitbucket or GitHub. I'm not sure if GitLab is available with that. They don't have great integrations with Google Cloud Platform, but nevertheless, you can mirror repositories. So if my repository is on GitHub, but I want to do stuff, it's sometimes easier, right, to to mirror that repository in cloud repositories on Google Cloud. And the reason I say that is because of authentication type things. So if I'm building something and I need to use code out of that Git repository, I actually need to store like an SSH key or something to go and grab that code from GitHub and get it onto Google Cloud. When you mirror the repository up onto Google Cloud, it's already in your cloud. So you don't need to do this weird authentication thing to the repository. And that can be really useful when you're building out CI/CD pipelines in Cloud Build and these types of things. It can simplify your life. Trust me, I've done it. So what we do is we would run this command here, right? It'll spit out an error. I created it earlier so that we wouldn't have to wait. But what it is it is the gcloud command, which is our main command we usually use for interacting with cloud APIs. Artifacts, repositories, create. We create something called hello repo. We define our project. Here it's pirate stops. You have a repository format of Docker, right? And oh, sorry. Okay, scratch everything I just said. This is not a Git repository. I apologize. This is an artifact repository. So, okay, back up. I mean, everything I just said was true and is true. But what we're creating here, and I apologize, is an artifact repository. So an artifact repository is different. Okay, so there used to be something called, and there still is, it's called Container Registry on Google Cloud. Container Registry is a place. So when you build a Docker image, they call it a Docker image, a built Docker container, it's called a Docker image. When you build a Docker image, it's a file essentially, or a group of files, and you need somewhere to store that, right? And so sure, you could put it into you could put the Docker file into Git, but putting your image into Git is not really a thing, right? But you still need a way to like have these built images kind of live somewhere. And so Docker Hub is very popular registry where you can find a lot of pre-built Docker containers. But Google also hosts its own private registry and public registry, I should say. And what you can do is utilize Google Cloud to have a private registry, okay? Now, it used to be you could only store containers there, but people kind of were like, it would be nice if I could store other stuff there, right? Like, what if I have pre-built Python packages that I also kind of belong with that container and other files like config files maybe, or, you know, all sorts of stuff could belong, not just the container, but a whole slew of other things could go with that, right? And so the registry was only for Docker or containers, right? Container images. Now, if I build, say, a Python package, I can actually store that on container registry as well. And what's cool about, or artifact registry, sorry. So on artifact registry, you can store all kinds of things. It's also more secure. For more information on that, you can go read about artifact registry, but it's a very cool offering that's kind of newer and they're adding more and more functionality, but it's a great place to store all kinds of things. And you can actually pip install straight from artifact registry. So if you create a Python package, you can store it there and install from there. Super cool. Okay, so sorry about that. A little confusing, but artifact creating an artifact repository, that's where we're going to keep our Docker image when we build it. Okay, so we created it. The format is a Docker image. Location, so the location, this is a region. US West 1 is actually Oregon. Description, you could have a more detailed description, in this case, Docker repository, right? Like it's a demo. So we can do, there's all sorts of places you can have your registry, but we're going to do it in Oregon because that's where we are, or I am currently. So I am biased. So here, what I've done, and I should have explained that probably before, but we'll highlight it right. So I said gcloud build submit, right? And what this command does is actually builds my Docker container. So I'm in the quick start directory. I'm in that Python directory. And if we remember what's in the Python directory, right, we did an ls, we have a Docker file in our app. So gcloud builds is a way I can build Docker containers, right? It's called Google Cloud Build. I can build Docker containers in Google Cloud. So sometimes you might be used to saying Docker build. It's the same type of command. And in fact, you can tie Google Cloud Build to Docker, the Docker build command. So when you're on your local computer, right now I'm in the cloud on a VM, but if you were on your local computer, you could say Docker build and it would automatically, right? You could set your default build to be sent to Google Cloud to be built instead. And that's really nice because, you know, if you have a really complex Docker container, you're having to pull down a lot of stuff, it's really going to be dependent on your internet connection. In this case, you just ship your files, right? I mean, it's still kind of dependent on your internet connection, but you ship your files to Google, your Docker file, any dependencies. But then all this stuff gets built inside on Docker Compute. So also if your laptop isn't that great. Like I used to develop on a Chromebook, like $100 Chromebook, but I was developing in Google Cloud. So it didn't matter. As long as my internet connection was good enough, I would just do that. And it was awesome. It was really awesome. So I use Google Cloud Build, and there's a very generous free tier. So don't even worry about it costing a bunch of money or whatever. And same with Artifact Registry, very generous free tier. It's based on Google Cloud Storage, which is very, very cheap. So highly, highly recommend getting familiar with both of those services. Notice the tag here, US West, right? That's where our Artifact Registry is, right? That we created. This is a path essentially inside our Artifact Registry, defining our Docker container. Okay, and if we go right, so now if we come out of here and we go to Artifact Registry, here it is, right? Well, let's first go to build. Actually, sorry, let's go to Cloud Build. So we go to Cloud Build and we see right here, this is the latest build, took 19 seconds at 5:57 p.m. It is now 6 o'clock, so that's our most recent build. And we can click on it and go in and see these build steps. So here's what it looks like. Our build was created, and there's different steps that were defined, right? And so what it ends up doing is actually because of how we tagged our Docker container. Okay, so this is actually directions. A tag can be directions on what registry you want to store it in. So here, because we use this specific tag that's used to store things in Artifact Registry, we were able to automatically, when we send it to Cloud Build, once it builds, it automatically says, oh, I know that tag. I know where that location is. And this is specifically for cloud or Google Cloud registries. You can do it for other ones, but you'd have to configure it. It automatically reads that tag, knows, and sends it to Artifact Registry. And so that's where our current container image is living. Here it is, hello repo, right? And if we look at that path, right? Right here, this is the registry, okay? We're in Pirate Stocks, that's our project, right? So here's Pirate Stocks up here, that's our project, also right here. So then hello repo, that's the name of our repo. So it's a larger repo, right? Like where we could store all the stuff that you can store in Artifact Registry, including Docker images. But then we say hello world GKE. Okay, and that's the name of the actual Docker image that we stored. And you see that here, and there's a little Docker symbol next to it. We can click on it, and this was all automatic. I just pushed it, and it just sent it here. You can see 4 minutes ago it was built. It's tagged with the latest. We could change that tag to be a version number of whatever we wanted, and we could deploy to all sorts of places. So notice, we could deploy to Cloud Run. We can deploy to GKE. We could deploy to GCE. Okay, and it will also show us the pull. Docker pull that, and we have the proper permissions set up. We can pull that to our local machine. We can pull it to a VM. We can pull it wherever we need to pull it. So lots of different configurations there. Okay, this is Artifact Registry, right? It's kind of connected to all of these things. And this is why it's nice, and also very secure, which is also very good. Okay. Woo! That was a lot. Any questions so far? Anything anybody wants to know? Jump on the mic, drop it in chat. Just let me know. Okay. While I get this ready. All right, we're going to jump into actual Kubernetes now. So now we've built our app, we built a container, we stored it, we put it on Cloud Build, we put it into Artifact Registry, and that's all sweet, right? So now we're ready to go to actually launch something onto Google Kubernetes Engine. Well, you have to define a cluster, right? We haven't defined a cluster, so there actually isn't anything. It doesn't come with like a default cluster. So when you start a project, you do need to say, hey, Google Cloud Platform, I need a cluster, and you got to define what that looks like. So I can show that here. So if we go to, let's just open a new file. It doesn't matter what we call it. We'll call it cluster.txt. It doesn't matter. I just want to show you this command. Okay, so here is the command that we would run. Okay, I'm not going to run it because I already ran it because it takes a minute to spin one of these bad boys up. But so the command is gcloud container clusters. Okay, that's how you interact with GKE specifically. We want to create a cluster called Hello World GKE. That's an arbitrary name, but it is unique, I believe, within the project. So it has to be a unique name within the project. So you have multiple clusters. You can't have like multiple clusters with the same name. Okay, so just be aware of that. The number of nodes we'll have is 1. So remember, we were looking at nodes where we can, the scheduler will schedule pods to be deployed, right? In this case, we only have 1 node. You might have 3 nodes, and in fact, you should have more than 1. Well, I shouldn't say that. You can have more than 1 node. We'll just leave it at that. And then we define a zone. So we're defining a zonal cluster, right? We could, remember, define a regional cluster that would then deploy across zones. Okay, so you could have 1 cluster, but it would be across multiple zones. Remember, we would do that if we want our app to be resilient and fault tolerant, all of those good things, right? So here we define US West 1A. Okay, so A is a zone within US West 1. Okay, and that's where our cluster will live. And we would run that command. And once that's run, we can say, we use our kubectl. Remember, I said that's how we're going to interact with the API. So once I build my cluster, I use kubectl and I say get nodes. Okay, hit enter. And lo and behold, here is our node. It's version 1.21.5-GKE. It has a name, right? A crazy name, right? With a unique ID attached to it, right? It's from the default pool. Definitely, if you're interested, look up node pools. Those are very interesting and very useful for certain deployments. We won't go over those here; they're a little outside of our scope, but definitely check those out. It's another offering from Google Cloud that's can be very useful. But you can see we ran kubectl get nodes, right? We said, hey, API server, right? Remember, hey, API server, give me the number of nodes. What did it do you think? Probably went to that etcd database and said, hey, how many nodes we got out there? Give me the names of them. And it sends that information back to us. Okay, so that's what we're doing. We're interacting with that API server. So what we want to do now that we know we have our deployment running, we want to deploy, our cluster running, we want to deploy stuff to it, right? That's the whole point. So we have a deployment.yaml here that I have pre-configured, right? Oops, okay. Don't want that. Okay, YAML is very picky, by the way. So be very, very, very deliberate in how you're spacing things and all that, because it will complain at you. And I have run into occasions where it takes forever to figure out what's wrong. It's not exactly intuitive. And there are tools like YAML linters and stuff. Highly recommend you use those. But nevertheless, this is a configuration file. This is what we would hand to Kubernetes, or I should say specifically, if you want to be more specific, the API server, to say, this is what I need to put on the cluster. And this is called declarative, right? Declarative configuration, okay? So when we say declarative configuration, right, it's directions on the state of the world. Why is this good? You can probably think of a couple reasons. One of those reasons is version control. The state of the Kubernetes cluster is stored on that etcd server, right? But we also want to store the state of the world. Like, we need to know what that is when we're developing, right? Like, we don't want to constantly be pinging the etcd server. When we have these YAML files, we can version control the state of our Kubernetes applications or our Kubernetes workloads through these YAML files. And this is really, really awesome, right? Like, so what we're saying is we specify the API version. So that's the right, should be pretty obvious, the API version. So this will live in app/v1, right? So that's the path to the API we want to use on the API server. We specify a kind. You remember I mentioned kinds. So there's different kinds of resources. We saw one kind, which was a pod. And you can specify pods, right? You could do that. But that's not really what you want to do, right? Because the problem with specifying a pod is it's not really controlled by anything, right? Like, so if the pod goes down, I mentioned, and I should back up and say, I mentioned that the controller is managing pods and all of that stuff. That was kind of a lie. And we'll back up on that a little bit. So the controller is technically doing that, but what it's basing that off of is something called a deployment, okay? A deployment is something that deploys something called replica sets. Okay, replica sets are the actual things, right, that are then deploying the pods, right? So a deployment basically, and that sounds very confusing, and I don't want you to think too hard about that. The main thing to know is that you never, ever really, I don't do it, you never deploy a pod. They call that a naked pod, right? Because it's not actually being managed by anything, right? What you need is to launch a controller, and the controller will control the number of pods that are out there. Okay, so, and then the controller, right, that you launch, like a replica set controller, that is in turn managed by the Kubernetes control plane, the main controller, right? And there's several, but I should say controllers, right? But those controllers look at those types of things, right? So there's not like a pod controller, right? There's different controllers depending on what you want to do that will launch pods for you. So just the main takeaway from that is never deploy a naked pod. You're never going to do that. You're always going to be deploying something else that will in turn be managing and deploying pods for you, right? And that's what actually manages the state or looks after the state of what you have declared that you want. So here, let's take a look at this. We're launching a deployment. This is called a deployment. And the deployment says, well, you can have the kind of deployment that you have metadata. So the metadata, you can give it a name. Here we're going to call it Hello World GKE. You can add labels, and labels are nice because if you launch something, let's say you launch multiple services in a Kubernetes cluster, you can use labels to act upon certain resources with a certain label. So if I, launch this app and I label it, oh my God, I don't know. Let's say I have multiple apps. I have app 1, app 2, app 3. So I want to do certain things to app 1, I want to do certain things to app 2, and I want to do certain things to app 3. But those are replicated across nodes, right? So I can't say, go to this node and do this thing, go to this node and do this thing, go to this node and do this thing. Instead, I would use what's called a label selector, and I would just say, anything that has this label, do this thing. Then I don't have to worry. Then I shouldn't have to care where that app is, where it lives, what it's doing. Just do that to that label, anything with that label, and that's what I want, right? And this is, again, that declarative style, right? So that's really, really cool and really nice. because I don't have to do anything but write this YAML file that says like do this thing to anything with this label, right? So definitely make use of labels, liberal use of labels and label selectors and all those types of things. So we define our replicas. Our replicas, we have one replica that we'll launch, and we'll actually show launching 3 replicas. We'll up this and decrease this. Okay, but for now we have one replica that we'll launch. Here you have your labels, right? So the label selector, we're gonna have our label be app as hello. Okay, well I should have read farther because there it is, right? We label it with hello, right? And our spec here, our name of our app, right? So here we come down to the containers. So all of that is just to define our Kubernetes resource. This is where the actual container is. So we say the name is hello app. The image is that, this should look very familiar, that Docker image, the registry, the project, the repo, and the image name. And we want the latest version of that image. The container port, so we open it up the container on port 8080, and we have an env, right? An env variable. If you noticed in our application when the server was being deployed, right? If we go back to our app, you can see here that it's looking at the port variable. It'll default to 8080, right? So we can define it on any port we want by defining, go back, by defining this value here. Okay, so notice we feed an environment variable value in here, and the value is 8080. It's kind of redundant, but nevertheless, it's fine. So that's our deployment file, and we will deploy this file. Oh god, I'm going to delete the file apparently. Okay, there we go. Get out of here. All right, don't want to ruin it. All right, so how do we deploy things, right? Well, we can do that. There's actually a lot of ways, and there's whole books on this, but we're going to use the kubectl command in this lab. So we'll say kubectl apply f, and we'll deploy our deployment YAML. Okay, so we say kubectl apply, that will apply it to our cluster, and we say -f for file, right? And then deployment.yaml, which is the name of our deployment file. And what we'll do is we'll hit enter. And you notice here, deployment.apps, right, / hello world -GKE, which is the name that we gave it, created. Great, right? Like all of the things that we've talked about are happening in the background. It's sending to the API server. The API server says you want a deployment, and then it tells the proper controllers. You need replica set controller, and the replica set controller tells the scheduler. Oh, the API server tells the scheduler, and then the scheduler schedules those on the nodes. In this case, we only have one node. But if we had multiple nodes, it would schedule out on multiple nodes, depending on how many replicas we have, so on and so forth. All of this is happening for us. And all we did was write a YAML file and say apply. That all gets handled for us, right? So now what we should see, right, if we say kubectl, right, we're going to query the API server to tell us, hey, give me all the deployments that exist on my cluster. Well, there it is. Hello world GKE ready 1 of 1. Okay, so we requested 1 and 1 is ready. There's 1 up to date, so it tells us that it is up to date based on the current state or the that we have told it the current state that we defined, right? And available, it is available, and it gives us how long it has been up. Done. We have a deployment. Great. That is super awesome. And you can also see we solve our pod, right? So, sorry, we have a pod. So here's our pod, right? So don't get confused between nodes and pods. Remember, nodes are the computers, essentially, right? Virtual machine, whatever it is, but the underlying computer that is running the pods, right? But the pod is that smallest unit. Notice how it got scheduled and it is now running. Okay? So now we can see our pod. Cool. All right. So let's go ahead and so I should say first, right now, our deployment is running. But we don't have a way to access our application. Why not? Well, because you know, there's no way to reach it, right? Like it's sitting on this random pod, right, out here on this random node, whatever node it got scheduled on. In order to do that, we would have to like port forward locally from the pod, which is totally possible. Yeah, exactly. Exactly. We could port forward from the pod itself, right? kubectl actually has, if you type in port forwarding, I think, forwarding, like that. Yeah, unknown command. It's like port. Oh, all right. Well, anyway, there's a command. Hold on. You know what we can do? We can do this. Grab port. Port forward. Okay, so my bad. So we'll say port forward. Okay, and then we can do a dash H. Dash H. Oh, so we can see here that you can actually port forward from your pod, right? If you want to. So I could port forward from my pod to 80, 8080, right? And then I could access my pod. But that's not a thing, right? Like you don't want to do that in production. Like port forward from a specific pod, because remember also, pods can go away. They're supposed to be ephemeral. Ephemeral means temporary, right? So there shouldn't be any reason, right? Like you shouldn't do it to a specific pod, because each pod will have a different name. So if you were port forwarding from a specific pod and that pod got reaped and then redeployed, it'll have a different name. So that port forward is no longer valid. So we need a constant, right? A constant way to access our application while being indifferent to whatever is happening with our pods on the back end. This is where a service comes in, okay? A service object. Here's our service object, right? So you see here our API version again, version 1, kind service, okay? You can think of a service, in this case, it's a load balancer. There's different types of services, but we're gonna go with our load balancer here. And we're gonna give it a name, hello, right? And a selector. Notice the selector, here it comes. Remember we had match labels on our deployment called app hello, right? By the way, this app is arbitrary. It could be any, but this is essentially just a key and a value, right? So you say select all pods with the label of app equal to hello, right? And what we want to do is we're going to open up our load balancer to take traffic on port 80, and the target port for the pods that are selected by our label selector will be 8080. Okay, so we're gonna attach to the pods at 8080, and the load balancer in front of those pods will serve traffic on port 80. So when we attach or connect to our load balancer, we will be able to, it'll direct us to a pod on the back end. Okay, so here we go. So again, we do kubectl apply -f service. And this works for all sorts of things. You can have secrets, you can have service accounts, you can have all ingress files, all this type of stuff. And it is the same command, kubectl apply -f your YAML file. Okay, lots and lots of cool stuff you can do with that. So anyway, so we apply that to our cluster. Bam, service hello is now created, right? Pretty straightforward. Now what do? Well, we want to check and make sure it's there. Get services. Well, there you go. Okay, so notice we have our service hello, the type load balancer, which is what we just said. The cluster IP, and then an external IP, which is still pending. It hasn't allocated us an external IP yet. We'll wait for it. We could put a watch on that. There we go. Oh, it's already here. Okay. If you don't know watch is a really cool command where you can, it's basically a while loop, and then you put a command after it, and it just waits for something to happen, right? So we'll see it here in a sec when I change the number of pods. So but anyway, you can see that, and I think kubectl has a native like watch command or something, but I just use watch. But nevertheless, we see that our service now has an external IP address. It has port 8080, and we are looking good, right? So we go to let's see. So what we want to do is we want to view that, right? Well, how do we do that? Well, we need that external IP address, right? So we copy that, right? And we go into our browser, and we go there, and lo and behold, hello world. There's our application. We were just load balanced. Now, note, there's only one pod, there's only one node. Okay. So in that regard, it's just sending us to a single pod on a single node. If you had multiple nodes, multiple pods, it would load balance to, again, wherever is the right place that it deems right, depending on, you know, utilization of something, right? Like CPU or like whatever the case may be, but it intelligently routes you to the back end. And actually what's sitting behind services on Google Cloud when you're using the load balancer type is I believe it's a regional load balancer. Okay, and what that allows you to do is when you set up that regional load balancer, you can change it. Yes, there are ways to configure how it does that. Again, that's kind of one of those things where, yeah, it's kind of one of those things where it's like, do you want to? Like, is there a use case for that? Because, you know, especially on GKE, the load balancer object is actually another service, right? That is part of Google Cloud networking. And so if you think you know better than Google Cloud load balancers, you can certainly do that. But the idea is that you can launch these things. You shouldn't have to worry about that, right? Like maybe you would need to worry about that if you were managing your own cluster, like somewhere else, like in a data center or whatever the case may be for like a large company or something. In the cloud, that's kind of one of those things that is kind of lifted off your shoulders a little bit. So I can't really think of a use case for that. There probably is, but I know it's possible. Yeah. But nevertheless, we see our app here, right? Cool. So now what we've done is we've spun up our cluster, we've launched our application, we set up a load balancer in front of it. Okay. Now, what if we wanted to change the number of replicas on the back end, right? So what if we wanted to change the number of pods that are running? Well, it should be noted that we only have one node, so it's kind of like a little doesn't really make too much sense, but never, you know, we can do it, right? So if we go to deployment, that's lowercase, deployment.yaml, and we go up to our replicas, right? What we can do is we can say instead of one replica, we can have, now let's go through. We have 3 replicas, right? So we say now we're going to tell the server that we want 3 replicas instead, right? And remember, the service is just a load balancer, so that is indifferent, and all of the networking will be configured for us on that back. So it will have that. All of them will have that selector label. So the controller will automatically know, hey, oh shoot, we need to reroute, right? Because there's this new pod, and so it does all the routing tables for you. And you can get deeper on that. There's lots of, it's cool to like go deep into that. Trying to think, VMware did a great series on their Lightboard. They had a Lightboard series like a long time ago that really dives a little bit deeper into that. There's also some cool courses on like the O'Reilly website that talk about that, and of course books, right? But we apply that YAML. So notice that it's been configured. If it's already, oh, and then we want to watch kubectl get pods. Happened so fast. But notice now we have 3 pods, right? We changed the state of the world, and all of those things happened for us, including the networking. So we didn't have to do anything but declare that we want something, the state of the world, to be something different, right? So we can still get nodes. We still have one node. All the pods are still living on that node. So if we had multiple nodes, they would be scheduled across the nodes, balanced more or less in some way, in an intelligent way on the back end. And then again, get service. Our service has not changed. The only thing that changed was the fact that now it will direct traffic to 3, right? Because of the node or the pod selector, the app selector, that the label that we defined. So now it knows, oh, now there's 3 pods I can direct traffic to. So it would direct to any one of those. So we can also, if you wanted to, you don't have to go to the browser. You can also just like curl, right? So you can curl that and you get the same thing. All right. Cool. That is the end. I will be cleaning this stuff up afterwards. I think you could, it's public right now, so you could probably just like curl that or whatever and get the same stuff. But we're right up against time. Are there any other questions that I can answer about anything that we did tonight, or any anything else that's kind of lingering on your minds before we wrap up tonight's meetup? Yeah, there's a lot of information, but probably watch it over and over. And I encourage you to watch other stuff too, because like I'm not like a networking engineer, and I'm not a Kubernetes administrator, right? I know enough to do things, but definitely if you're wanting to dive even deeper, there's so many good resources out there. Up and Running with Kubernetes is a really great book for that. And then there's also like Cloud Native Kubernetes. Oh, okay, yeah. For GCP, also visit their YouTube channel and check out their cloud blog. Those are 2 resources that are really great. Their YouTube channel has some great tutorials and stuff. And then of course, just check out the documentation. They actually do have really good documentation that has a bunch of tutorials. So if you're wanting to go further, right? Like, so say you wanted to build a CI/CD pipeline, that tutorial there is a more advanced tutorial. It takes the same idea of what we just did, but actually sets up the cloud source repository that we were talking about, the Git repository, and allows you to trigger builds that get automatically deployed to your Kubernetes cluster. So it's kind of a step above this. Here we manually did it, but in reality, that's not something you want to do. The big thing, if you want to look up something that is really actually the way that all this is supposed to happen, you're not usually going to be using kubectl, like I said. What you're really going to be doing is probably doing something called GitOps. And what GitOps is something where you define, right, you put your files, your YAML files into a Git repository. From there, everything gets triggered. So application deployments are triggered off of those YAMLs that you put into your Git repository, and the state of your cluster gets updated automatically. So you're never directly really interacting with your cluster unless you're debugging or checking something, right? But the idea is that you should just be able to send your YAML files and version control your YAML files in a Git repository. It makes updating applications easier. It makes rolling back applications easier. This way that you're not needing to, apply everything, right? Like here, it would be ridiculous to be trying to apply every YAML file, because you can have upwards of a lot of YAML files, right? Best practice also says, one thing we didn't do here, you can actually define multiple kinds of objects in a single YAML file. So if you have an application that has like a service and all this stuff, you can put that all in a single YAML file too. So that's, but nevertheless, GitOps is a big deal. Yeah, there's a lot to dive into here. If you're fresh on Kubernetes, you're new to Kubernetes, this might seem like a lot, and it is. And I didn't know anything about Kubernetes a couple of years ago. Like I had to kind of build my way up. I used to just be Docker Compose and Docker containers and like all that. And once I got to the cloud and really started needing to learn this stuff, You know, it was kind of just forced upon me, which I was happy to do because it's really cool. But definitely dive deeper. Definitely check out as many resources as you can until this stuff makes sense. But hopefully this video was a good introduction where you can like, hopefully I explained it in like a way that you can understand as a beginner, not too familiar with Kubernetes terminology, because sometimes I find these tutorials and these books are just like a little heavy. So hopefully this gives you a running start on all of that stuff. Okay. Yeah, it's a valuable skill. It is incredibly valuable. And for the cloud, I mean, it utilizes exactly what the cloud is for, you know, the scaling, the networking, all that stuff, right? I mean, the Kubernetes and the cloud are a match made in heaven. So to really take advantage of that, learning Kubernetes is definitely something that you should familiarize yourself with. And in terms of cloud platforms, just in general, you know, you said you're AWS. I would just say, try to just pick one. Like, I mean, I teach GCP because I know GCP, but that doesn't mean like AWS is better. I mean, all right, I have some biases, but nevertheless, just pick one, right? It could be Azure, it could be AWS, it could be GCP. Just, you know, the concepts are the same across all cloud platforms. The services are different, but the concepts are pretty much the same. So just pick one and learn the hell out of it. That's always my advice with programming languages, anything in tech. Just pick one thing when there's a lot of things to choose from, and just learn the heck out of it. That's the best way to go about it, so you don't have information overload, because there's enough of that already. Yeah. So right, so when you're thinking Kubernetes, there are ways to store state. Yeah, the program I made doesn't even have any state, right? It's just saying like hello world, right? Let's say you wanted to store some values in some database or something like that. You know, so coming from this GCP side, right? There's Cloud SQL. Let's say you needed a SQL database. Well, there's all sorts of databases. Just pick one. We'll say, what if we needed a Cloud SQL database, like, or a SQL database? So you could use Cloud SQL, and then there's something called the Cloud SQL proxy that you can use in what's called a sidecar pattern. So you deploy that with each pod, and that gives each pod access to that Cloud SQL database so that they can store their state, right, in that Cloud SQL database. So as the pods go up and down and maybe destroy your cluster and bring it back up, all the state is still kept, right? So that the database is not dependent on whether those pods are coming up or down, or the state of your cluster, right? It's separated out from that. So again, you're designing Kubernetes, usually designing Kubernetes in a way that, you know, you understand that these pods are ephemeral. So you never are storing state within a pod. There are always caveats, but in general, that is true. Yeah. Yeah, exactly. So there's other ways to do it. I mean, you know, within clusters, within Kubernetes clusters, there's also something called volumes, right? So you can have volumes. In GCP, what you end up doing is you can spin up a persistent disk, which is basically a hard drive, right? Like an SSD or an HDD, persistent disk. And then you can actually mount that to the nodes in the cluster, right? So then you can have this virtual disk that is essentially mounted as what's called a Kubernetes volume, and the pods can then write or read from that volume, so they can save things there. So when that pod goes away, doesn't matter, right? Like that state is still kept. And if that node goes away, doesn't matter. That persistent disk still exists. So there's many different configurations that you can do to persist state beyond the life of a node or a pod. So yeah, those are excellent points. I know it's a black hole, and there's a lot that goes with it. But those are kind of some general patterns that you should think about and follow when you're, you know, when you're working with Kubernetes and containers in general, right? Is always thinking about, how do I keep from having my state stored in the container, right? Like, where is that going to live? It is very rare that it will live in a container, and actually, in my opinion, it should never live in a container. A container should be able to be destroyed, and you shouldn't lose anything, right? Awesome. Okay, well, I think that's enough overload tonight. Awesome, I'm glad you liked it. Yeah, definitely. Totally. Yeah. Oh, great. Good. Yeah. Set up your billing. Totally. Set up your billing and you should be good to go. There are some APIs that you'll need to enable, but the directions are all in those tutorials that I posted. So if you have any questions, join our Slack channel. Feel free to drop them in there. I'm happy to answer questions there. And there's other people there too with knowledge on that stuff. But other than that, I'm going to cut it off for tonight. Let you go explore your newfound Kubernetes skills. And I'll post this video. Like I said, it'll be up hopefully by end of day tomorrow. And we will see everyone next time. And thanks for coming. I appreciate it. Have a good night.